For my biofuel, I decided to talk all about renewable diesel. Some introduction and background on it. Renewable diesel is also known as green diesel, and it's made from biological feedstocks like vegetable oils or animal fats or used cooking oil. And it's chemically similar enough to petroleum diesel, so it meets the same standards as it. And then right here on the bottom, you'll see a drawing. That's a cycle of the biodiesel energy. So the solar energy is given to the oil crops and then transferred to regular transportation, which is then transferred to oil refineries, then transferred to biofuel, and then transferred to heavy transportation. And from there, carbon dioxide is released, and it's just a continuous cycle. So it's also grown in two main categories, crop-based oil, which includes canola, soy, or sunflower or palm. And this is similar to other oilseed crops in the sense that they're both grown through standard agriculture, which includes fertilization, irrigation, and harvesting. Photosynthesis is important here because the crop oil production depends on the photosynthesis converting the carbon dioxide and sunlight into plant biomass. And then the other category is waste and residue lipids, where used cooking oil and industrial plants are collected from restaurants. And this doesn't need any new cultivation since it's a circular feedstock, meaning that it's just reused over and over again. So, and then on the right is the hydroprocessing drawing, which is going to be explained on the next slide. But the inputs have feedstock and hydrogen, and when heat and pressure are applied, they go into the separator, which releases water, and then they're distilled into renewable diesel. So again, over here, there are two main production processes, which include hydroprocessing and pyrolysis. So hydroprocessing is the most common method. The feedstocks like cooking oil or animal fats react with hydrogen when there's a catalyst present. And when this happens, oxygen, sulfur, and any excess impurities are removed, leaving us with a clean hydrocarbon fuel that we know as renewable diesel. Then in pyrolysis, wood waste or plastics are heated to really high temperatures whenever oxygen is absent, and this will break the material down into a bio-oil, which is a liquid that can be upgraded into a hydrocarbon fuel. Um, and then photosynthesis is really important here in fixing the carbon dioxide into biomass and lipids, which is then used as the feedstock. And then for fermentation, the sugars are converted into bioalcohols like ethanol, and then they're produced further to create a source of fatty acids for biodiesel. Um, and then as for development, renewable diesel is commercial in many different regions, mainly in California, but it's also in many parts of the US and Europe. Lots of industrial facilities have converted or created brand new units to make renewable diesel. And there are some issues that come with this, including quick capacity additions that have occasionally exceeded financing and demand markets. So the impact on the carbon footprint. Life cycle greenhouse gases depend on feedstock and supply chain decisions. Renewable diesel is made from waste feedstocks like cooking oil, which can yield bigger greenhouse gas reductions versus petroleum diesel. And it's got a life cycle reduction of up to 85% when compared to petroleum diesel. Renewable diesel also reduces tailpipe pollutants like particulate matter and carbon monoxide. The economic impact, renewable diesel has created more jobs and increased economic activity in agriculture significantly. It also includes potential benefits to consumers by providing lower field prices. However, the stability of this depends on factors like production costs and government subsidies. The price and availability of feedstocks aren't fixed, so this could also be a potential risk. Many companies and distributors communicate renewable diesel to the public. This includes Nestle, Chevron, Diamond Green Diesel, Diesel Direct, and Global Partners. Going deeper into two of these, Nestle is a large production and distributes Nestle My Renewable Diesel. It communicates with the public through its website and different media sources. And Chevron advertises its different offers through articles and news releases. So for my analysis and recommendation, renewable diesel is a practical tool for heavy-duty transport. Greenhouse gas savings are substantial when they're made from waste and residue lipids. The main risks associated with it include feedstock constraints and unpredictable changes in the economy. I believe these are minimal. They're very important, but if we had like an unlimited money source, we could counter this by prioritizing waste and residue streams for producing and designing various policy incentives that would be predictable in order to avoid unexpected oversupply.